lives in South Africa.
We are Ayash
Casey
and Shrishti
from the East London Science School, and we're going to tell you about the research we've been doing for our attempt to race into space.
For the research part of our project, we decided to split up into 4 different groups. Each group carried out research at a different part of the project. The subjects that we looked at were the atmosphere, the flight, the design, and the payload.
We looked at what the atmosphere is like and what the temperatures are. It's important to know this because we want to get our balloons to get as high up as possible, and there might be things that, like the wind, that can stop it. We also need to know how cold it gets so we can make sure the camera and things that we put in the balloon will work properly.
The official start of space is 625 miles above the Earth, where there is no atmosphere at all. But almost all the atmosphere is within 30 miles above the Earth. Balloons can get about 20 miles. The part is called near space. This is in the middle of part of the atmosphere is called the stratosphere, where the temperature is about 10 degrees Celsius. Before you get to the stratosphere is the troposphere underneath. The temperature can reach under minus 50 degrees Celsius.
We think it will take up about 3 or 4 hours to reach space and come back.
As the balloon moves into the troposphere, it will get very, very, very cold. That will be colder than the North Pole. This means that we have to test all our equipment a lot to make sure it works during flight. The coldness will also change as the balloon flies. The coldness will also change how the balloon flies. This is because when gas gets very, very cold, its pressure drops. This will make the balloon very floppy and it might not be able to climb higher. We will also have to think carefully about how to fill our balloon with gas and what gas is better to use.
The troposphere is also where the clouds and the winds are, and so it will be the most dangerous part for our mission. The balloon can get destroyed here or blown a long way off course. So we will have to watch the weather closely and choose a good day to launch our balloon where weather is very good. If the weather is good and the balloon comes back to Earth, then we think it will land within about 50 miles of the takeoff place.
We think that in South Africa you won't have any problems with the weather, so it must be much easier for you there.
The troposphere is where planes fly to. So in Britain, we have to get official permission to launch our balloon. We have to launch the balloon from a special field not far from Cambridge University, and we'll have to tell the authorities some dates when we will try to launch it. This makes it even more difficult because we don't know what the weather will be like then.
In South Africa, do you have any rules to follow to launch your balloon? Do you think yours will be much easier to launch?
When the balloon reaches the stratosphere, it will start to heat up again. This will make it expand again. So we will have to make sure that it doesn't burst. This means that we'll have to worry about it getting too cold and too warm.
We have already started to have some thoughts about what our designs are going to be, but we have to keep them a secret. This is a competition, remember.
But we know that what goes underneath the balloon is called the payload, and it must not be too heavy because it will stop the balloon going as high as possible. In Britain, there are also rules about how much stuff you can take up into the atmosphere of the balloon.
We think that we should make the shape of the balloon and the payload aerodynamic. This means that it will be in a shape that allows air to flow over it smoothly, and it helps the balloon glide upwards.
We watched some films that other people have made, and it looks like our payload might spin around here. That's something else we need to think about.
It would be good if the payload could have our school logo on it too. And when we buy the balloon and the equipment, we will have to try to make everything very colourful. We know that you like things to be colourful in South Africa because you are the Rainbow Nation. So we will have to try and compete with you on that too.
The payload will basically be a box. All we know at the moment is that it has to be very light, but at the same time it must be able to withstand the weather and very cold temperatures.
The box will have a camera inside to prove that we have been up in space. We've done some research on the cameras that will do the job for us, but they are very, very expensive.
Some people put their camera on an arm, comes out the side of the box so they can take a photograph of the actual balloon in space. But we think this will be too hard.
We would also like to have sensors on board so we can measure other things like the speed of the wind, but we don't know yet because we don't know how heavy it is. The sensors will need batteries as well, and batteries are a real challenge. They will need to keep working for a few hours, even at really, really low temperatures.
Our local supermarkets sell batteries that claim to be the world's longest lasting. They look really useful, but we won't know if they survive at really cold temperatures.
Everything in the payloads will have to be tested at low temperatures. And to do this, we were going to try to use liquid nitrogen.
So those are our ideas so far. Now we have to sit down and work out a design and then test everything really well. We think this will be a really exciting and interesting part of the project.
We're really looking forward to hearing about your ideas and maybe stealing a few that we haven't thought about. Good luck and speak to you soon.
Game on! May the best team win!